In the autumn of 1974, deep within the closed military-industrial complex of the Soviet Union, a team of engineers gathered around a blueprint that defied every conventional notion of what a land vehicle could achieve. Their goal was not merely ambitious, but bordered on the fantastical: to build a car capable of exceeding 1,000 kilometers per hour, a speed that would shatter all existing records and demonstrate Soviet technological supremacy in the most dramatic fashion imaginable. This machine would not rely on traditional piston engines or even rocket propulsion, but on the raw power of turbojet technology, the same force that propelled fighter aircraft through the stratosphere. The project that emerged from these deliberations would become known as the Reaktivny, and its story reveals not just an engineering achievement, but a window into the psychology of late Soviet ambition, the desperation to prove relevance in an era when the space race had concluded and new arenas for technological competition were desperately needed. The context for this extraordinary undertaking cannot be separated from the broader trajectory of Soviet prestige projects in the 1970s. By this point in the Cold War, the initial euphoria of Yuri Gagarin's space flight in 1961 had long faded, and the American moon landing of 1969 had dealt a psychological blow to Soviet claims of technological superiority. The Brezhnev era, often characterized by stagnation in political reform, nevertheless witnessed continued investment in spectacular demonstrations of engineering prowess. The Soviet leadership understood that technological achievements served dual purposes. They validated the communist system's capacity for innovation and provided tangible symbols of national pride that could be broadcast to both domestic and international audiences. Land speed records, though perhaps less glamorous than space exploration, offered a relatively accessible arena where Soviet engineers could demonstrate their capabilities without the astronomical costs and risks associated with manned spaceflight. The institutional home for this project was the Central Aerohydrodynamic Institute, known universally by its Russian acronym SAGI, located in Zhukovsky, a closed city southeast of Moscow. Founded in 1918 by Nikolai Zhukovsky, the father of Russian aviation, SAGI had been responsible for virtually every significant Soviet aircraft design throughout the 20th century. By the 1970s, it employed over 15,000 scientists, engineers, and technicians operating wind tunnels, test facilities, and computational centers that rivaled anything in the West. The decision to house the land speed record project within SAGI rather than in an automotive design bureau was itself revealing. This was to be fundamentally an aeronautical project that happened to remain in contact with the ground, not a car in any conventional sense. The chief designer appointed to lead the project was Viktor Petrovich Makiev, a veteran of the Soviet jet engine program who had worked on the Tupolev Tu-1, 144 supersonic transport and various military aircraft power plants. Makiev understood that the fundamental challenge was not simply generating sufficient thrust, which turbojet engines could readily provide, but managing the complex interplay of aerodynamic forces at speeds where the vehicle would be operating in a regime more familiar to aircraft than automobiles. At 1,000 kilometers per hour, equivalent to approximately 620 miles per hour, or Mach 0.82 at sea level, the vehicle would encounter compressibility effects, shock wave formation, and aerodynamic heating that no previous land vehicle had faced. The project would require expertise from multiple disciplines: jet propulsion specialists, aerodynamicists, structural engineers, and material scientists would all need to collaborate in ways that transcended traditional bureaucratic boundaries within the Soviet system. The selection of the power plant began with a survey of available Soviet turbojet engines. The team initially considered adapting the Tumansky R-11, the engine that powered the MiG-21 fighter, which produced approximately 56 kilonewtons of thrust. However, calculations quickly revealed that achieving the target speed would require something substantially more powerful. The solution came in the form of the Tumansky R-15B300, the engine designed for the MiG-25 Foxbat interceptor, one of the most powerful aircraft engines in the Soviet inventory. This remarkable power plant could generate over 100 kilonewtons of thrust and had been designed to operate at speeds exceeding Mach 3 at high altitude. The R-15B300 represented the cutting edge of Soviet jet engine technology, incorporating advanced materials and cooling systems that allowed sustained operation at extreme temperatures. Securing authorization to use this engine, which powered a frontline military aircraft and was classified as a state secret, required approval from the highest levels of the Soviet defense establishment. The design of the vehicle itself presented challenges that pushed the boundaries of existing knowledge. Mikhail and his team began with fundamental questions. Should the vehicle have 3 wheels or 4? Where should the engine be positioned? And how could they minimize aerodynamic drag while maintaining stability? Wind tunnel testing at SAGI's facilities revealed that a long, slender fuselage with a narrow frontal area would be essential to reduce drag. The team settled on a configuration that placed the pilot in a reclined position near the front of the vehicle, with the massive turbojet engine positioned behind the cockpit and the jet exhaust extending past the rear wheels. The vehicle would ride on 4 wheels, with the front wheels closely spaced for minimal drag and the rear wheels positioned far apart for stability. The entire structure would be approximately 12 meters in length, roughly the size of a single-seat fighter aircraft, but would weigh only about 4,000 kilograms fully fueled, extraordinarily light for a vehicle of such dimensions. Materials selection became a critical concern as the engineering progressed through 1975 and into 1976. At the speeds envisioned, aerodynamic heating would raise surface temperatures to levels that would destroy conventional automotive materials. The team turned to aerospace-grade aluminum alloys for much of the structure, supplemented by titanium in areas of highest stress and temperature. The Soviet Union possessed extensive experience with titanium fabrication, having pioneered its use in submarine construction and aircraft manufacturing. But working with this notoriously difficult material required specialized welding techniques and quality control procedures. The landing gear, which would need to withstand not only the vehicle's weight but also the tremendous aerodynamic loads at high speed, was designed using components adapted from fighter aircraft, with wheels and tires specially developed by Soviet aviation suppliers to operate at ground speeds far beyond anything previously attempted. The question of where to conduct the actual speed runs presented its own set of complications. The vehicle would require an absolutely flat, smooth surface extending for at least 15 kilometers to allow for acceleration, the measured kilometer, and deceleration. Weather conditions would need to be carefully controlled, with minimal wind and no precipitation. Security requirements dictated that the location be within the Soviet Union, and preferably in an area already under military control. After evaluating several options, including dry lake beds in Kazakhstan and closed military airfields, the team selected the Baikonur Cosmodrome complex in Kazakhstan. While Baikonur was primarily associated with space launches, the facility included extensive support infrastructure and, crucially, a concrete runway that extended for over 6 kilometers, with flat desert terrain beyond that could be prepared for the speed runs. The symbolic resonance of using the same location that had launched Gagarin into space was not lost on Soviet planners. Construction of the vehicle, designated Reaktivny 1, proceeded through 1976 at a facility within the TSAGI complex. The project operated under conditions of strict secrecy, with access limited to personnel holding appropriate security clearances. The Soviet system of closed cities and compartmentalized information meant that even within SSAGI, knowledge of the project was restricted to those directly involved. Photographs and technical documentation were classified, and the team worked under instructions that no information about the project was to be shared outside official channels. This security regime, while typical for Soviet military-industrial projects, created challenges for the engineering team, as it limited their ability to consult with specialists outside the immediate project group and prevented them from accessing certain Western technical literature that might have informed their work. The selection of the pilot was entrusted to the Soviet Air Force's test pilot program, which maintained a cadre of highly trained aviators responsible for evaluating new aircraft designs. The chosen pilot was Colonel Vladimir Nikolaevich Zaitsev, a veteran test pilot with over 3,000 hours of flight time in various jet aircraft, including the MiG-25. Zaitsev had experience with high-speed flight and had demonstrated exceptional reflexes and judgment in emergency situations, qualities that would prove essential given the experimental nature of the vehicle. At age 42 in 1977, Zaitsev represented the ideal combination of experience and physical capability. His training for the Reaktivny 1 runs included extensive simulator work, study of the vehicle's aerodynamic characteristics, and practice runs in a modified vehicle at progressively higher speeds to familiarize himself with the handling characteristics. By the spring of 1977, Reaktivny 1 was complete and ready for initial testing. The vehicle was transported by military cargo aircraft to Baikonur, where a special team had prepared the test surface. The runway had been meticulously inspected and resurfaced where necessary, and surveying equipment had been installed to precisely measure the vehicle's speed through the measured kilometer. The first series of tests in April 1977 focused on low-speed handling and systems checks, with Zaitsev conducting runs at speeds up to 200 kilometers per hour to verify that all systems functioned as designed. These initial tests revealed several issues, including vibration problems with the landing gear and difficulties with the braking system, which had to be redesigned to handle the enormous kinetic energy that would need to be dissipated during deceleration from maximum speed. The breakthrough came on the morning of June 21, 1977, under ideal conditions: clear skies, minimal wind, and moderate temperatures. Zaitsev was strapped into the narrow cockpit, his body reclined at a 45-degree angle to reduce frontal area. The R-15B300 engine was started, its distinctive howl echoing across the empty steppe. As Zaitsev advanced the throttle, the vehicle began to accelerate, slowly at first, then with increasing rapidity as the turbojet reached full thrust. The acceleration profile was unlike anything experienced in a conventional vehicle. The continuous building push of 100 kilonewtons of force driving a 4,000-kilogram machine created acceleration exceeding 1 g, pressing Zaitsev back into his seat with force equivalent to his own body weight. Within 30 seconds, the vehicle had exceeded 500 kilometers per hour. Within 50 seconds, it had reached 800 kilometers per hour, and the aerodynamic forces were creating a deafening roar as air compressed against the vehicle's surfaces. At 63 seconds after throttle up, Reaktivny 1 entered the measured kilometer at a speed of 972 kilometers per hour. The timing equipment, calibrated to microsecond precision, recorded the vehicle's passage through the kilometer in 3.68 seconds, corresponding to an average speed of 979 kilometers per hour. Zaitsev continued accelerating, and peak speed reached approximately 1 kilometer beyond the measured section, touched 1,014 kilometers per hour before he throttled back and deployed the braking systems. The deceleration was violent, with drogue parachutes deploying first to provide initial braking, followed by wheel brakes that glowed red-hot from the energy absorption. The vehicle came to rest nearly 10 kilometers from the start point, having consumed its entire fuel load and having subjected every component to stresses at the absolute limit of their design specifications. The achievement was immediately classified at the highest level. Unlike Western land speed record attempts, which were conducted openly with extensive media coverage, the Soviet leadership decided that Reaktivny 1's success would remain a state secret. The reasoning behind this decision reflected the complex psychology of Soviet secrecy culture in the Brezhnev era. On one hand, the achievement represented exactly the kind of technological triumph that the Soviet system valued, and that could bolster national pride. On the other hand, revealing the project would expose details about the R-15B300 engine, the materials and construction techniques used, and the capabilities of Soviet engineering in ways that might provide intelligence value to Western adversaries. Additionally, there was concern that international recognition would require submitting to verification by Western organizations, a process that would involve allowing foreign observers into sensitive facilities, something the Soviet security apparatus was unwilling to permit. The decision to keep the project secret meant that Reaktivny 1 never received official recognition from the Fédération Internationale de l'Automobile, the international body that certifies land speed records. The existing official record at the time, set by Gary Gabelich in the Blue Flame rocket car in 1970, stood at 1,014 kilometers per hour, coincidentally almost exactly the same as Reaktivny 1's peak speed. However, Blue Flame used rocket propulsion rather than a turbojet, and the two vehicles represented fundamentally different approaches to the same challenge. Without international verification, Reaktivny 1's achievement remained unknown outside a small circle of Soviet officials and engineers, a ghost record that existed in classified files, but not in public consciousness. The technical data gathered during the Reaktivny 1 program proved valuable for other Soviet engineering projects. The experience with high-speed ground aerodynamics informed the design of experimental ground effect vehicles and ekrenoplans, the massive wing and ground effect craft that the Soviet Union developed for military transport. The materials and structural techniques pioneered for Reaktivny 1 found applications in aircraft design, particularly for high-speed interceptors and reconnaissance aircraft. The braking systems, which had to dissipate enormous quantities of kinetic energy, contributed to improvements in aircraft landing systems. In this sense, the project justified itself not through public recognition, but through the diffusion of knowledge and techniques throughout the Soviet military-industrial complex, a pattern typical of how closed Soviet research programs generated value. Additional runs were conducted through the summer of 1977, with Zaitsev and a backup pilot, Major Anatoly Sergeyevich Lebedev, making a total of 17 high-speed passes. The vehicle proved remarkably reliable and with the R-15B300 engine performing flawlessly despite operating in an environment quite different from its designed aircraft application. The highest speed recorded during this test series was 1,047 kilometers per hour, achieved on August 12, 1977, a figure that represented the absolute limit of what the vehicle could achieve with the available thrust and the aerodynamic configuration. Calculations suggested that reaching significantly higher speeds would require either substantially more power or a complete redesign to reduce drag, both of which would have required resources that were not allocated to the program. By late 1977, the Reaktivny 1 program was quietly concluded. The vehicle itself was returned to Tazaji, where it was placed in secure storage. and the test site at Baikonur was returned to its primary space launch functions. The engineers and technicians who had worked on the project were reassigned to other programs, carrying with them the knowledge and experience they had gained, but prohibited from discussing the details of what they had accomplished. Zaitsev continued his career as a test pilot, eventually retiring with the rank of Major General, but he never spoke publicly about Reaktivny 1 during the Soviet era. The project reports, technical drawings, and test data were classified and filed away in the archives of TAAG and the Ministry of Defense, where they would remain inaccessible for decades. The story of Reaktivny 1 might have remained permanently hidden had it not been for the collapse of the Soviet Union in 1991 and the subsequent gradual declassification of previously secret projects. In the early 2000s, as Russian archives began to open and former Soviet engineers felt free to discuss their work, details of the program began to emerge. Articles in Russian aviation journals mentioned the project, and Zaitsev, in an interview published in 2004, provided the first public account of the speed runs. Photographs of the vehicle, taken during the 1977 tests, were declassified and published, showing a sleek silver machine that looked more like a missile than a car. Its narrow fuselage dominated by the massive intake and exhaust of the turbojet engine. The revelation of Reaktivny 1's existence sparked debate among land speed record enthusiasts and automotive historians. Some argued that without contemporary international verification, the achievement could not be recognized as an official record. Others pointed out that the technical documentation and photographic evidence, combined with the testimony of multiple participants, provided compelling proof that the speeds had been achieved as claimed. The question of whether Reaktivny 1 should be retroactively recognized as having set a land speed record remains unresolved, a testament to how Cold War secrecy created ambiguities that persist decades after the conflict's end. From a technical standpoint, Reaktivny 1 represented a remarkable achievement that demonstrated the sophisticated capabilities of Soviet aerospace engineering at its peak. The successful integration of a frontline military jet engine into a ground vehicle, the solution of complex aerodynamic problems, and the development of materials and structures capable of withstanding the extreme conditions of near-sonic ground speeds all testified to the depth of expertise within the Soviet engineering establishment. The project showed that when Soviet engineers were given clear objectives and adequate resources, they could match or exceed Western achievements, even in domains outside their traditional areas of focus. Yet the decision to keep the project secret also revealed the fundamental contradictions of the Soviet system. The entire purpose of prestige projects, like Reaktivny 1, was to demonstrate Soviet technological superiority and generate positive publicity for the communist system. But the security apparatus's instinct for secrecy meant that this publicity could never be realized. The project succeeded brilliantly as an engineering exercise but failed completely as propaganda because no one outside a small group of insiders knew it existed. This pattern repeated itself across numerous Soviet programs, where impressive achievements remained hidden for decades, their potential value as tools of soft power completely unrealized. The fate of the Reaktivny 1 vehicle itself remains somewhat unclear. According to some accounts, it was eventually scrapped during the chaotic 1990s when many Soviet-era projects were abandoned or dismantled. Other sources suggest that it may still exist in storage at TSAGI or another facility, though its condition after decades of neglect would likely be poor. The R-15B300 engine, assuming it was removed from the vehicle, would have been valuable enough to be preserved or reused. The loss or destruction of the vehicle, if it indeed occurred, represents a tragic erasure of an important piece of engineering history, a physical artifact that could have served as a testament to the ambitions and capabilities of its creators. The broader significance of the Reaktivny-1 project extends beyond its immediate technical achievements. It exemplifies the Soviet Union's approach to technological competition during the Cold War. The marshaling of enormous resources and talent towards specific, clearly defined goals that could demonstrate superiority over Western rivals. This approach produced spectacular successes in areas like space exploration, military aviation, and nuclear technology, but it also revealed the limitations of a system that prioritized prestige projects over broader economic development and consumer welfare. The thousands of hours of engineering time and the substantial financial resources devoted to building a vehicle that would make fewer than 20 runs and would never be publicly acknowledged might have been directed toward projects with more practical applications. But such considerations were secondary to the imperative of demonstrating Soviet capabilities. Looking back from the perspective of the 21st century, the Reaktivny-1 project appears as both an impressive technical achievement and a symbol of misplaced priorities. The engineers who designed and built the vehicle were clearly talented and dedicated professionals who solved difficult problems with creativity and skill. The vehicle itself represented a remarkable synthesis of aerospace and automotive technologies, pushing the boundaries of what was possible with the materials and knowledge available in the 1970s. Yet, the decision to pursue the project in secret and the subsequent inability to leverage the achievement for any broader purpose reflects the pathologies of a system that valued secrecy and control over openness and the free exchange of ideas. The story of how Soviet engineers built the first turbojet race car to exceed 1,000 kilometers per hour is ultimately a story about ambition constrained by ideology, about technical excellence undermined by political paranoia, and about achievements that remained invisible because the system that produced them could not allow them to be seen. It reminds us that technological progress does not occur in a vacuum, but is shaped by the political, social, and institutional contexts in which it takes place. The same Soviet system that enabled the concentration of resources and expertise necessary to build Reaktivny-1 also ensured that its success would remain hidden, its lessons unshared, and its potential impact on Soviet prestige unrealized. In the end, the vehicle that was built to demonstrate Soviet superiority became instead a metaphor for the contradictions that would eventually contribute to the system's collapse, a brilliant achievement locked away in darkness, known only to those who created it and forbidden from taking its place in the broader history of human technological achievement.